Edge ST8 strengthens its industry leadership and efficient 3D product design. This latest release further integrates synchronous technology into proven large-scale assembly modeling techniques. In this demonstration, we'll make several changes to a workbench stand supporting a recovery robot's chassis. New time-saving file open functionality identifies top-level assembly files, letting you quickly retrieve the overall assembly without having to search through a long list of sub-assemblies. Here we'll open the top-level workbench stand assembly. Leveraging the power of synchronous modeling speeds design changes. To stabilize the workbench fixture part, we'll widen its base just by dragging its side face, and we'll define a small offset to get an exact fit. Edge specializes in providing all the tools you need to work on a part within an assembly. We'll activate the base plate part to implement some changes. Notice how Pathfinder indicates your active position within the assembly structure. Here, we want to remove material from the base plate to ensure a tight fit between the stand and robot chassis. We'll subtract material using the bottom of the chassis. Access to the top-level assembly components was crucial to get the correct result. Notice the result after removing material using the top-level assembly components. A perfect fit. This approach produces accurate results and maximizes your productivity. Design reuse averts time-consuming and costly model recreation, so we'll make use of geometry already present in the top-level assembly. Watch as we use sketches from the workbench stand to create a relief pocket on the base plate and remove unnecessary features. Finally, we'll add some rounds to remove sharp edges and finish the base plate. With Edge working on subsystems and components within a large assembly is efficient and very fast. Streamlined weldment design is delivered in Edge ST8. The ability to create weld beads within the part environment gives you flexibility with the use of standard weld bead commands, part modeling techniques, or a combination of the two. With weld beads defined in the part environment, you have full control of the material definition, appearance, and access to their mass properties. We'll continue to work in a top-down design scenario, as this gives easy access to the assembly components. Here we'll create weld beads between top-level components while in the part environment. Their material is defined in the part, not the assembly. Now that we've applied weld beads to one component, we can expedite the welding process to the other side with the use of duplicate part. Now that's easy, it's fast, and it greatly streamlines the welding process. When you need to efficiently document your weldment scenario on a drawing, Edge shines. Watch as we place standard and auxiliary views with minimal mouse clicks. We'll apply a cutting plane to the front view, and from that cutting plane we'll pull a detail view to note information about the weld beads. Since we can extract weld bead information directly from the model, we save time and cut costs by avoiding duplication of effort. If a design change is approved, it'll be reflected throughout Edge. Watch as we return to the assembly and increase the weld bead size between the post and fixture. Back in the draft environment, we're notified that a dimension moved, but also notice in the parts list the weld bead weight and cost also reflect the changes. Edge with synchronous technology frees you to design more productively with the best tools and technology to get your job done right the first time. Edge. Design better.